Hello students, so today we are going to discuss solar radiation, heat balance and temperature. This is the second part of this chapter, and in the previous part we discussed about the introduction and we discussed about the solar um radiation. Right now this is the second part, so here we will discuss about the variability of insolation at the surface of the earth. So students, here now in this, the amount and the intensity of insolation vary during a day, in a season and in a year. The factors that cause variation in insolations are, so here I'll tell you 5 points regarding this. First is the rotation of the earth on its axis. Second is the angle of inclination of the sun's rays. Number 3, the length of the day. Fourth is the transparency of the atmosphere. And the fifth one is the configuration of land in terms of its aspects. So if we're talking about the rotation of earth, because here these all 5 points we will discuss one by one. If we talk about the rotation of the earth on its axis, now because of the rotation of the earth, in some part it is day and in some part it is night. Not only that, the earth is continuously rotating, it completes on rotation in nearly how many hours? 24 hours. So when a complete day completes, so during this time we can see day and night. So and in different parts of earth, the weather conditions also, time of day different, so we can say there is variation in insolation. Right, next is the angle of inclination of the sun's rays. So this depends on the latitude of a place. How? Suppose I'll show you through this map. Here this is sun, right? This is sun, and in front of this just have earth, right? And here you can see latitude. This is the equator, right? And you can see the sun rays like this. Okay, so higher the latitude, less in the angle. Higher the latitude, less in the angle, they make the surface of the earth resulting in slant rays, sun rays. There are covered by vertical rays is always less in slanting rays. Okay, this is vertical rays and this is slanting rays. So you can see less sun rays reached in this part, and in this part when the sun rays isn't vertical, so it takes extra heat. So there are the area covered by vertical rays is always less in the slanting rays. So in more areas is covered, they their energy get distributed and the net energy received per unit area increases. Moreover, the slant rays required to pass through greater depth of atmosphere, resulting scattering and more absolution. Okay, absorption. There you can see here, this is through this diagram you can understand it better way. Now number 3 is the transparency of the atmosphere. Okay, the transparency of the atmosphere, this is the third point. Sorry, it's mentioned in your book. Firstly we will discuss about the transparency of the atmosphere. Right, so atmosphere is largely transparent to short waves solar radiation, so that we receives our short waves because they directly come and hit the surface of the earth. It means the atmosphere has clearly in it. The atmosphere is in continual continually motion, changing temperature, air current, and causing stars to twinkle. Okay, if stars twinkle, this is all the cause of the transparency of the atmosphere, right? So within the troposphere, the water vapor and ozone O3 and other gases absorb much of the near infrared radiation. Do you know infrared? Okay, so due to in the troposphere we can see vapor, water vapor, H2O and ozone, O3 and other gases absorbs much of the near infrared radiation. And when I say infrared, it means heat of the sun. Very small particles in the troposphere scattered. Okay, so it's scatter visible spectrum both to the space and towards the earth surface. So this process add color to the sky. This is also a cause it's add color to the sky. The red color of the rising and setting sun and the blue color of the sky are the result of scattering of the light within the atmosphere. Okay, understood. Now the next is the length of day. So students, the length of day, the earth exists mix in angle of, like this is earth, so you can see this is equator portion, and here this part, this is 90-degree angle, and here this is the portion is of 66.5 degree, and this is sun. Here you can see slant rays and vertical rays. So the earth exists mix in angle of 66.5 degree with the plane of its orbit around the sun, and has a greater influence on the amount of insolation received at different latitude. Okay, in different latitude. Each and every day planet exists in a different place. Okay, planet exists in a different place. Due to this, there is variation in day and night because of the revolution. In day and night because of the revolution around the around the sun. Right. Now the next is configuration of land in terms of its aspects. So here student, this depends on the latitude of a plane. Higher the latitude is, the less is the angle. Vertical rays is always less than the slant rays, because slant rays, students, you can see if the sun rays moves in a vertical, so it will be short. When sun rays moves in a slant, it's, so you can see the distance, vertical rays is less than slant rays. Okay, so which is already we have studied in the previous part. This is slant and this is vertical rays. So next is the spatial distribution of insolation at the earth surface. Right? Spatial distribution of insolation at the earth surface. So students, this part I'll explain in the next video. Till then, revise this topic, whatever I have explained, because these are very important. If you will not be able to understand these topics like variability of insolation at the surface of earth, solar radiation, so it will be a little bit difficult to understand the next one. Okay, so till then, revise this, keep revising, keep study. Thank you so much.